going on, everybody? So, we got the last new thing that I have to do with you guys for the year right here. Starting tomorrow and next week is just review stuff. You have no final, just review. So, pretty much the way it's going to go is next Friday is going to be like the last day of something that I'm going to assign for you guys. And then the following week, which would be the last full week of school, is the time to make up anything that you could possibly be missing. So I'm hoping you guys are all going to be on the right page and you'll be good to go. Overall, I'm like, as of right now, I just saw I got like 6 or 7 emails of people turning in some assignments, so I'll make sure to get in and grade those for you. Hey, what's going on, Tabitha? So I think we should all be good. I'm not 100% sure, but I think we are. So I only have 2 questions for you guys today. It should be a pretty quick lesson. So this is what we did yesterday, page 1. We did a little graph. We talked about some range and some amplitude. We're going to talk about the same kind of stuff on the back page in numbers 4 and 5. Number 5 is going to be a little bit easier than number 4. So I'll start with the more difficult one first, and then we'll move on to number 5. So, in exercise number 4, it says that you have the height of a yo-yo above the ground can be well modeled using the equation h equals 1.75 cosine blah 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 blah, where h represents the height of the yo-yo in feet and t represents the time in seconds that since the yo-yo first dropped from the maximum height. Okay, so I'm going to draw a small little graph. You guys don't necessarily need this graph, but I'm just showing you what the graph would look like. If we have a yo-yo, it starts off in your hand, and then you swing it so it goes down to the ground, and then eventually the yo-yo is going to come back up. If we were to graph that over time, the height of this yo-yo is going to go down, come back up, go back down, come back up, and it's just going to keep doing that forever and ever and ever. So it's starting, so this is like your hand. This is like the ground down here. I want it to be a straight line. So the yo-yo, if you're doing the yo-yo correctly, you don't want it to hit the ground. You want it to be just above the ground. So it's just going to keep going up and down as many times as you do it. So they gave us an equation for this. And it says that we have that 1.75. I'm just going to rewrite this right now. 1.75 cos pi t plus 2.25. So this represents the formula for height. So it says determine the maximum and minimum heights of the yo-yo and show the calculations that lead to that answer. So I like doing it with pictures. That's why I drew the graph over here. Some of you guys have gotten pretty decent at this without using graphs. Some of you guys could do this right off the top of your head. So if you look at the equation I just rewrote, the part that we always start with in that equation was our midline. So our midline in this case is representing that 2.25. So again, I like doing it this way. You don't need to, but I know that oh, that wasn't a straight line. Tabitha's going to say something. There we go. All right, so we got 2.25. That's our midline. So we need to find the maximum and minimum heights. In order to do that, that's where the amplitude comes into play. The amplitude tells us how high we go and how low we go. So I'm going to highlight that part next. So the amplitude is that number that's at the beginning. So that's telling us how far up we have to go. So we have to go up 1.75. But it's also telling us how far down we have to go. So we also have to go down 1.75. So essentially, this is telling us, take the midline, and we're going to add, let me write this out twice. So we're going to take the midline and we're going to add the amplitude, but we're also going to subtract the amplitude. And that will tell us the highest point of the yo-yo and the lowest point of the yo-yo. So if I do the top one, 2.25 plus 1.75 is going to give us 4 feet. And then if we subtract it, I believe that's at 0.5. So it's asking for the max and min. We now have the max and min. The max is at 4 feet, and the min is at half a foot. It's at 0.5. That's all part A was asking us. That's it. Now the next one says, how much time does it take for the yo-yo to return to the maximum height for the first time? So what they're asking is how long does it take for one cycle from the yo-yo to go from your hand down towards the ground back to your hand? So the only part we care about right now, I can't use that color. I got to use a different one. We'll do orange. It wants to know from the start back to that height. So we only care about that little portion that I highlighted. Well, the time is represented by this number right here. So it's where it ends. And you guys may recall the word that we use for the ending time is known as the period. Okay, apparently it wants to create a circle. All right, period. So all I'm asking is, how long does it take for one cycle? Well, the period formula was P equals 2 pi over B. So I'm going to go back to my formula because we do know what the B value is. It's in the formula. The B value is what you're multiplying the time by. It's what you're multiplying theta by or x by. In this case, it's t. So all I'm going to do is plug the pi in for the b down here. So it'll be 2 pi over pi, which just means the pi's are going to cancel out. So the period is 2. We just have to make sure we put down the units. And if we go back up and look at what time was, it says time is in seconds. So we would have to just state that it takes 2 seconds for the yo-yo to go from the hand to the ground, back to the hand. Okay? So you didn't need a picture at all to solve this out. I just like showing the picture because I believe it makes it a little bit easier to understand. If you guys understand that finding the range is just taking the midline and then adding and subtracting that amplitude, that's all you have to show. If you know that the period is this formula, that's all you have to show. Okay? So that was the more difficult question of the two I was going to show you guys today. Yeah, stop by, Sierra. I'll definitely be there. Sorry to storm out on you guys. I just had the pool guy came. We finally got our pool set up. Of course, we're getting the pool set up when the weather's going to switch back to 60 degrees starting this weekend. But I don't know how to set up a pool, so it's easier to hire a guy to do that. But yeah, stop by tomorrow Zoom, and I could sit down and go question by question to make sure you're all right. Exercise number 5 is actually just part A from up top. So it's the same thing. Yeah, we actually just got him a shark life jacket. So he's actually going to wear it, and it has a little fin on the back. It comes this weekend. He has a mini pool that he goes in all the time. So he goes inside his mini pool, and he just walks around, and he doesn't want to lay down in the pool. He likes laying down in mud puddles instead. So that's great. But, alright, so exercise 5. This one is just like 4A. So it says Evie figured out how figured out that the equation represented by her on a swing is h equals 3 cos pi over 2 t plus 5, where t represents the time in seconds. Determine the range of Evie's heights. So we could draw the swing if we really wanted to, because the swing is going up, and then you're going to come and swing all the way back to the other side, and then you're going to swing over. So if I were to graph it, again, this is not necessary, but if I were to graph this, what the swing's doing is it's saying, hey, you're probably starting a couple feet off the ground. You're going to start swinging until you start swinging backwards, and then you're going to come back to the original spot. Because technically, since you're swinging forwards and backwards on the swing, part of it's going to be negative because you're going backwards as you're swinging. And you're just going to keep doing that forever and ever and ever. And I could just keep drawing that. But that's just whatever. Again, the graph doesn't really matter. I just wanted to show you guys so you understand what's happening. Now, I'm trying to get you guys to understand how to do this algebraically, so you don't need the graphs. If it helps you understand, that's why I like showing it, Shannon. So, if you look at what the equation states, if you're ever looking for the range just means that you guys need to know what your midline is. So that's all this really means. If you ever see the word range, it means find the midline. And we can find the midline. I know you guys are good at finding that. The midline is just that 5 at the end. But you also have to find the amplitude. Which again, I know you guys can find the amplitude. It's just the number that's at the beginning. It's your A value. And what you're going to do is just take those two numbers and you're going to add and subtract them. That's all range means, because you're looking at how far up the amplitude goes and how far down the amplitude goes. So now that I have that, what I'm going to do is just plug in those numbers. So the first number is 5 because that is the midline. I'm going to add and subtract the amplitude, which is 3. So I just have to find those two answers. So if I split them up, I'm going to have a 5 plus 3. I'm going to have a 5 minus 3. So the 5 plus 3 gives me 8, and the 5 minus 3 gets me 2. So this one is my max, and this one is my min. And again, if I were going to show it in the picture, what this is saying, and I should have drawn I just randomly drew this over here. It's not, actually I could fix this pretty easily. It says the midline is supposed to be at 5. So I should change my x-axis so it's down here. So it's saying that the midline is right through here and that number is at 5. And it's telling us based on the amplitude that from that 5 we have to go up 3, but we also have to go down 3. So I'm showing it to you guys algebraically, but on the graph, it's still the same thing. You're still going to be adding 3 above and you're subtracting 3 below. Okay? So that's all I got for you guys. Finding the range should help you guys out, as well as finding the period should help you guys out for tonight's homework, which is that Unit 11, homework number 11. So the first one is kind of going through all that, finding the maximum height, finding how many seconds. Number 2, you'll see minimum and maximum. It's telling you what the range is. It wants you to find the equation. So go through those. I mean, if you got trouble, you got trouble. That's okay. Don't be afraid to ask. I'm here. And that is the last new thing. I'm not teaching any new stuff from here on out. So starting tomorrow, I'm going to give you guys a Unit 11 review sheet, which is going to cover, I think I only did like 6 or 7 questions on the review sheet, and it's going to cover what we did throughout this unit. And then next week, I'm just going to kind of give you guys, like we had those benchmark reviews. So I'm only going to focus on Unit 10 and Unit 11 because those are the only ones that we did on the computer. I'm not going to go back and do units 1 through 9 because we already did a big review on that when this whole pandemic began. So 10 and 11 are going to be the ones that you guys are going to focus a lot of time with in Math 12 and Algebra pre-calculus. So in pre-calculus and Math 12, most of you guys are going to be taking one or the other next year. We're going to be doing a lot of Unit 10 and Unit 11 stuff, so that review will definitely be helpful for you guys. All right, but yeah, that's all I got for you today. Go out and enjoy this beautiful weather because we're supposed to be getting thunderstorms tomorrow if it shows up. But yeah, I hope you guys have a great time. Stop by Zoom if you guys need to. I will be there. And yeah, that's it. I will catch you guys later.